now going to introduce the Interpolate node, which is a little bit more advanced. The Interpolate node essentially calculates the intermediate values between an initial and target value over a set amount of time. This is commonly used in animation, as it allows an object to be animated from A to B. We are going to be using it to animate some subtle background assets, which you can find in the Asset Manager in the Effect folder. Let's grab all of the assets except the one called Decoration and then drag them into our scene. What we want to do with these assets is slowly rotate each of them at different speeds to create a pulsing effect. First, let's put them in the right place using our well-known frames. I will speed this up a bit since I explained it few videos before. Be sure to end like I did. I created a frame for each asset and called them Effect 1 to 3, then group them and give it the name Background Blur. If we drag them now over into the logic editor, we have them all ready to be animated. To do that, let's right-click the logic graph and type Interpolate, then hit Return. Now you can see that this node has quite a lot of sockets, which I will go through one by one. The Start socket here triggers the start of the interpolation because we want this to play from the start of the scene. Let's connect the on-scene show event listener to this socket. Now the next one is Duration, which is also available as an attribute. This is the complete length of time in seconds it takes to get from the start value to the end value. For now, let's set this to 20. The interval time attribute is how often in seconds the value is updated. Let's leave that on 1 for now. The next two attributes are from and to. These are the start and end values. Because we want to rotate a full 360 degrees, let's set these to 0 and 360. The next category of attributes relate to how the values are interpolated. The most common interpolation type is linear interpolation, which means that the values will be changed in a straight manner over time. The other types, which include the word ease in their name, relate to whether the interpolation type eases in, eases out, or eases both in and out. The words circular, cubic, etc. are all different strengths of easing. There, for our purpose, we are just going to be sticking with the linear interpolation type. The next option is the mode. This allows us to decide between 3 options. Alternate, once, and repeat. We want this to repeat. So let's select repeat. We also have the option to specify the amount of times the interpolation should be repeated using the count attribute. But we want it to loop indefinitely, so let's enable the infinite toggle here. Now, let's set it up so that we can multiply the rotation amount by adding a multiply node, and then putting the interpolation value into its first input, and then setting the second input attribute to 2 for now. Then let's add a set rotation node as we did earlier, and then link the graphic, called Effect 1, to the object ID, and then connect the output of the multiply node to the rotation. Now if we go back to the main window and hide the other 2 effect graphics for now and then press play, you should see a subtle background blur effect. So you can see the basic functionality of the interpolation node and how it affects the animation of these graphics. Now I want to take the same logic that we made in the previous video and apply that to the other acceleration graphics. Let's first create a variable to hold this interpolation value so that we can decouple our logic as we did in the previous lesson. So let's go to the Variable tab and add a new variable which we'll call effects_base_rotation, which will be a float, and then drag it to the graph to create a setter. And let's reconnect these connections, delete these ones here. Then create our onChange event, which we will need 3 of. So let's select the node and press Ctrl D twice to duplicate it. Now if we drag this logic over here and think about how we will approach this, you can see that all 3 of these nodes will need to be repeated, because the second input of the multiply node is going to be different for each image, and the set rotation node will also have to be duplicated. Like I discussed in a previous video, you should always try and find a way to not repeat logic. If we look at our logic, we will see that the things that will be different for each graphic is the object ID and input 2 of the multiply node. So what we can do then is create what's called a function, which basically allows us to package up a set of self-contained logic with its own user-defined inputs and outputs, which can then be reused across your entire project as a custom node. So, if you go over to this tab here with the FX icon, you can create a function in the same way that you create a variable. So let's click the plus icon, and let's call this rotate_effects. So before we go into this function, let's select these nodes here and press Ctrl and C to copy them. Then double-click on the function to open its own logic graph. And then press Ctrl V to paste the nodes into the function. You'll see here that there are two nodes, which we didn't paste in, which are called function input and function output. If we click on the function input node and look at its attributes, we can use the plus icon here to add sockets to our custom node. If we go back to the scene graph and first delete these nodes and then drag the function to the main logic, you can see that those inputs are now added to the node. You can then double-click on the node to go back to its logic graph, where we can modify these input sockets to fit with our needs. So the first input will be the amount that the rotation should be multiplied by, so let's call this multiplier and change its type to float. And the second input is the object ID, which we will call object ID, and change the type to be object ID. So now let's connect the function input pulse to the multiply node and the multiplier to its input 2 socket and the object ID to the object ID socket of the set rotation node. Let's also create a getter for our effect-based rotation variable. And then plug that into the input 1 socket of the multiply node. And finally, let's plug the output pulse of the set rotation node into the function output node. Now if we go back to the scene graph, we can duplicate this function twice and link up the object IDs. Then for the multiplier inputs, let's add a simple node called numerical value. And this is basically an alternative to creating a variable, and is more useful when you only want to access the value in a single place. Before I duplicate this a couple of times, I need to make some space to have everything a bit more structured. Let's connect the pulses quickly and set the default value of the numerical value to 1. Then duplicate it twice and set the default value to 2 and 3. And of course, let's link up these to the multiplier sockets. Now before we press play, let's unhide the other two graphics and then hit the play button. Now we can see the subtle effect in the background of our speed meter, created by all these graphics rotating at different speeds. I hope you found the entry-level tutorial helpful. The goal was to get you into the main concepts of how to work with Incari. In the future, I will post more tutorials to showcase even more cool stuff. See you soon, and have fun working with Incari Studio.